So let's do a full example for the normal distribution. Okay, so here let's say the GPAs of a large population of university students are approximately normally distributed. Okay, I know that they're normally distributed because it just told me that. Okay, let's say the average GPA of the students is 2.4 and the standard deviation of the students is 0.8. Okay, so here let's see some things. Let's see that the area between 0 and 1 standard deviation is approximately 34%. And let's see that the area in between -2 standard deviations and +2 standard deviation is somewhere around 95%. Okay, so we can do this. Okay, there are two scales going on. In terms of GPA, the middle is 2.4. Plus 0.8, so one standard deviation above the middle is 3.2. Two standard deviations above the middle is 4.0. All I've done here is 2.4 plus 0.8. 3.2 plus 0.8. Okay, I can do the same thing for the negative standard deviations. Okay, also we can talk about the Z-scale then, of course. Here, if you want the Z-score of 3.2, we have 3.2 minus the middle, divided by the standard deviations, and you can see that that is 1 standard deviation. Okay, so let's see that in between 0 and 1 is about 34. I want to show you two different ways that you can do this. In between 1 and 0. Okay, 1 and 0 when I'm talking about Z. See how Z is in the middle here. Okay, so what's the probability of in between 1 and Z? Probability model, this is normal. In between 1 and Z is going to be, I've got it in column 10. And if we've got 50% minus 84%, looks like the difference is somewhere around 34%. I want to show you that if I talk about the scale of this being in between here, 0 in the other scale is called 2.4. 2.4 is the average. And here, in between 2.4 and 3.2. Okay, so instead of talking in Z scores in between 0 and 1, let's talk about GPA scores in between 2.4 and 3.2. You can also use Minitab to do this. You can say here, instead of the middle being 0, the middle is actually 2.4. Instead of the spread being 1, we're not talking about Z scores, we're talking about the spread actually being 0.8. We saw the middle was 2.4 and the standard deviation was 0.8. Okay, so then let's talk about what is the area in between column 11. Okay, so here notice the thing that's very, very, very important. This is in X scale, this is in X scale. When I did column 10, that was in Z scale, and the mean was 0 and the spread was 1. This was also in Z scale. They have to be consistent. Okay, so here, what I get is, not surprisingly, the exact same numbers. I can talk about Z scales, I can talk about X scales. Okay, so there you can also see that it's about 34%. You can do a similar exercise to show this, but let's go to something a little bit more interesting. Let's talk about some notation. This statement is saying that in between the value -1.66 and some unknown value that I'm calling Z0, the area of that is 0.35. Let me draw this in pictures. This is hard to understand, so I need to draw it in pictures. What it's saying is in between the area here of -1.66 and in between this value, which apparently is called Z0, I know that this amount of area is 34%. So I want to find out what is this value. Okay, that's the thing that's unknown. Okay, so what can I do to find this out? The thing that I can do first is to find out what this area is. Okay, if I know what this area is, and then I add whatever this area is to this area, then I can get the cumulative area to this point. Okay, so here, let's do this in steps. Let's first just find what this area is. Okay, so here I want the cumulative area of Z is -1.66. Okay, this is Z. How do I know it's Z? Because it says it's Z. Okay, so when you're talking about Z, the middle is always 0, the spread is always 1. I want the cumulative area of -1.66. It tells me this area is close to 5%, about 0.0485. Okay, so then in total, this area now from the start all the way to this point is 0.0485 plus this 35% that was in between these two. Okay, how much area is that? If I add these two values up, I now get this picture, 0.3985. Okay, so the area from the start, the cumulative area, to this unknown point, Z0, that's the cumulative area. Okay, I can do this in Minitab to find out what Z0 is then. Okay, so here I've got the area, I want the value. Okay, when you have the area and you want the value, you need to use the inverse cumulative option. If I'm talking about Z's, I have this middle is 0, the spread is 1, and the cumulative area I said was 39.85, if I remember it correctly. I hope that's right. Then the corresponding Z value is negative 0.258, or negative 0.257. Okay, so you can see then this missing value, what must it have been? It must be negative 0.257 standard deviations, Z value. Okay, if I wanted to convert this then into a GPA, okay, so here I've got this in terms of standard deviations. But instead of standard deviation, so here this is negative 0.257, which is, so in terms of Z, here's 0, here's negative 1. Negative 0.25 is somewhere right around here. So what GPA is this going to be? Okay, so it's going to be a little bit less than 2.4. It's going to be more than 1.6. I want to know what GPA it is. All I need to do is use my Z formula. Okay, remember the formula. Let me just quickly go to it. Here is the formula right here. Okay, I have a Z. I'm trying to figure out an X. I know the middle. I know the spread. Okay, so let's go back. I know that the Z, I've just calculated. The Z is negative 0.257. The X is the thing I'm trying to find out. The middle, we said the average was 2.4, and the standard deviation was 0.8. So if I take this 0.8 and I multiply it by this value, and then I add 2.4 to isolate for X, I will solve for X, and I'll find that this is a GPA of 2.19. Okay, so here, if I'm talking about this value in terms of Z, it's negative 0.25. In terms of X, or in terms of GPAs, the context of the data that I'm talking about, it is 2.9. 2.19 is right here. Okay. So here, let's talk about this even more in depth. A student claims to be the 90th percentile. Okay, so what that means is 90% of the class is lower than they are. Okay, so 90th percentile means they're doing very well. They're doing better than 90% of the class. What is their GPA? Okay, so here I've got 90% of the data is below this point. Okay, this is called the 90th percentile. I want to know what their GPA is. Okay, there's a lot of different ways that you can do it. Let me show you, let me show you two ways. Okay, I'll go to Calc, Probability Distribution, Normal. Okay, here if I'm talking about the Z distribution, the middle is 0 and the spread is 1. I've got an inverse cumulative area, so I'm saying here the cumulative area is 90% or 0.9. In terms of Z's, that value is 1.28, okay, 1.28. Then I can use your Z formula to solve for what X is. So here Z is 1.28, mu is 2.4, standard deviation is 0.8, and I can solve for X. Okay, the other way that you can do this, if you know Minitab, and you have to be very careful. Okay, lots of students mess this up. Okay, here, if I don't want it in terms of Z scale, if I want it in terms of the X scale, I'll change that the fact that the X scale's mean is not actually 0, it is actually 2.4. That is what I expect. That is the average. Okay, what is the standard deviation? In terms of GPA, it is not 1, it was 0.8. I can still do the 90th percentile, but this time find it in terms of X, in terms of GPA. Okay, whether I put this value into my formula and solve for X, or I can do directly, I can find that the student that is the 90th percentile, they have a GPA of 3.42 or whatever, 3.45-ish. Okay, so either way you do it, you should get the right answer. Okay, finally, very tricky. 35 students are randomly chosen. Okay, the GPA over a semester was observed. What is the probability that between 7 and 10 inclusive have a GPA of at least 3.2? This is very, very, very tricky question. You might get a problem like this on your second midterm, so pay attention. Okay, so first of all, I need to, instead of thinking about 10 students or 35 students or 7 students, let's just talk about 1 student. Okay, so here, what's the probability of having at least a GPA of 3.25? Okay, so here in terms of x, I've got 2.4, I've got 3.25. I'm talking about at least, so here at least is the greater than or equal to sign. I want this shaded area. Okay, so what I can do is convert this into z's. Okay, so here, how do I convert this into a z? I take this value, 3.2, I minus the mu, the mean, and I divide by the standard deviation. In terms of z, this value is 1.0625 in terms of z. If I want to find this area, I can. Okay, I really don't want that area, I really want this area. I'll find this area first, and then I'll do 1 subtract it to find this tail area. Okay, so here in terms of z, I've got 1.0625. Okay, again, that was a z calculation. Okay, when I'm talking about z, the middle is 0, the spread is 1. I have the value on the bottom, I want the area. This is the cumulative probability. Okay, if that's true, then I can put 1.0625. Again, this is a z value, 0 and 1. I get that area there. The other way I could have done this, if I wasn't talking about z values, if I was talking about GPAs, okay, the scale was, the middle was 2.4 and the standard deviation was 0.8. What is the probability that I'm higher than 3.25? Notice here I get the exact same number whether I'm talking about z's or whether I'm talking about x's. I have to be consistent. When I was talking about x's, this was the mean, this was the standard deviation. When I'm talking about z's, this is the mean, this is the standard deviation. The area, either way, of this cumulative area is 0.85, so forth. Okay, so I do 1, subtract that, and I find the probability of this tail is 1 minus this, okay, which I've estimated to be about here 14.4%. Okay, that is just the probability of 1 student having a GPA larger than 2.5. Now we'll deal with the fact that we've got 35 students. Okay, let x be the number of students out of 35 with a GPA higher or equal to 3.25. This actually is binomial. We've got 35 students to choose from. The probability of having a GPA of a larger than 3.25, we just found to be about 14.4%. Okay, so here I needed to use the z distribution to find the probability of success. Now I'm using that probability of success in a binomial way. Okay, so this is tricky. Okay, so what is the number of students out of 35 that have a GPA of at least 3.25 or higher? We want to know the probability of it between 7 and 10 students, including those endpoints. In between 7 and 10 of the number of students. Okay, binomial is a discrete distribution. We have to be careful. Okay, so in between 10, in between 7, what I want is the cumulative 10 subtract a cumulative 6. That will give me 7, 8, 9, and 10 all together. Okay, in Minitab I can go to Calc, Probability Distribution, Binomial. Here I want the cumulative probability, number of trials is 35, the event probability we found from the normal distribution to be 1.44, and here the input constant is 10. Okay, that's the cumulative probability of having at most 10 students. I want the cumulative probability also of having 6 students. Okay, these two areas are my cumulative areas. If I take the difference between those two areas, I get the probability of having between 7 and 10 students of having a GPA of 3.25 or higher. That would be 22%.